All right, guys. We'll just wait a little bit and see if we have a couple other people joining us. Hopefully we do. So while we're waiting, did everyone have a nice extra long weekend? Just open this up here. Yeah, that's no problem, Ethan. It's good to hear. Mine was nice. We had the weather was beautiful, so it was very nice to have 4 days to kind of relax a little bit. So just to give you a sense of where we're going and what we're doing, today we're going to finish off the notes on joints. On Friday, we'll talk about some conditions related to joints and muscles. And then on Friday, so Friday will be a fairly short lesson. Today will be kind of short, but I did assign a worksheet, which I put off already or sent off already on Google Classroom. And that's just for joints. That'll be due on Friday. And then on Friday, I will assign a joints project after we talk about some of the conditions. So you'll have a project kind of, or not a joints project, a musculoskeletal conditions project. So I'll assign that to you on Friday. I just have to put my finishing touches on it. So you'll have time to work on that over the weekend. That'll be due next Wednesday. And then on Monday, yeah, I think on Wednesday. On Monday, we'll just do the last finishing touches about having a healthy musculoskeletal system. So we'll do some notes on that. And then on Wednesday's class, we may or may not have one on Wednesday. We'll see. And then on Friday, we'll see where we're at on Wednesday. On Friday, the following Friday, not this Friday coming up, but the following Friday will be your, I'll open up a final exam for this. So actually on Friday, we will move on and start talking about our sports med, which is our last unit. Okay, so that will be not this Friday, but next Friday, where we'll start taking a look at our very last credit, which is for sports medicine and nutrition. So a lot of it is stuff that you probably heard before. Some of it will be new, but that's what we're going to be doing. Okay, so for today, we're just going to finish off the joints. So let me just open that up so we can all see it. And where are we at? Second here. There we go. Let's just go backwards here. So I think I'm just going to do a real quick rundown of what we've talked about, and just to remind you, and then we will finish this off here. So I'm just going to move that up, move this over, and just really quickly, we'll just quickly run through as a quick review. So remember, fibrous joints are the immovable ones. They're made out of a fiber, so they tend to be more in our skull area. Cartilaginous joints are made out of cartilage from the name, right? And they're partially movable, and wherever we see the cartilage here between bones. So cartilage between bones is typically what we'd have as a cartilaginous joint. So between our sternum and our ribs, we would count those as cartilaginous joints. Here in the pubic bones, there's a cartilaginous joint, the pubic symphysis, which actually really loosens up a lot when a woman is in labor and giving birth. And then we have these joints here between the vertebrae, okay? So a little bit of movement, and then freely movable is our synovial joints, called that because between them there's synovial fluid, and then there's all the little components that make up the synovial joints. Okay. All right, so we need to make sure that we're knowing the different components that make up a synovial joint. So we want to make sure we're understanding ligaments, the joint capsule, which is like the sleeve that goes over the two heads of the bone that make up the joint, the synovial membrane, articular cartilage, and then the joint cavity, which we know is filled with synovial fluid, which is kind of like a really thick sort of egg white like material. And ligaments, we want to make sure we know what all of these things are for. So ligaments are to hold the bones together at the synovial joint. So we see a ligament here, we see ligament here, right? So we talked about some ligaments that are in our knee and some that are in our ankle. Obviously, we have ligaments all over the place that are holding these joints together, but these are just a couple of examples that I showed you. Okay, so they help to stabilize the joint. Articular cartilage, that's found at the end of our bones that are making up the joint, typically at the ends of our long bones, okay? And it prevents friction when those bones are moving together so they can glide past one another nicely, okay? The meniscus, so I added this slide after we talked about this, but it is on Google Classroom. The meniscus are little pads of cartilage that help the bones fit a little more tightly together. Okay, so that's what meniscus is. So we have these in our knees, we have this in our wrists. So we see meniscus here in our wrist. We have them in the joint here where our jaw moves, okay? And then we talked about bursae. So those are little sacs that are filled with synovial fluid, and they can prevent friction between bone and other tissue, and then they can also act as shock absorbers to absorb a shock, so there's not as much impact on your bone. Okay, and there's some examples of where bursae is found. All right, and then we talked about the 6 different types of joints. Okay, so the ball and socket joint, a ball fitting in a socket. This is the joint that gives us the most movement. So the 2 prime examples of that are in our shoulder and in our hips. Okay. Hinge joint, okay, 1 movement, so it's like a hinge. So that's what we see here in our elbow. That's a hinge joint, movement in 1 direction. So it's just changing the angle. The angle can get bigger or smaller. I'm looking at the angle here, in this case, between my forearm and my humerus. Right? So my elbow joint, the joints in my phalanges. The pivot joint allows us to pivot. Okay, so that's what I'm going to see in my cervical vertebrae right underneath my skull, so I can look left and right. I also see that in the proximal area of my ulna and my radius. So that's up here by my elbow, and that's what allows me to do this, a supination, supination and pronation. Okay. All right. The gliding joints, so these are what allow bones to kind of slide over one another. So this is mostly we're looking at the little cubical or cuboidal shaped bones, the ones that are shaped like cubes, so our short bones. So wrists and ankles. We have the condyloid joint. So we see this in our knuckles, and it allows movement in 2 ways. So it allows movement this way, but allows movement back and forth this way. So we have 2 different directions of movement. Okay, so we can see that in our image here. Okay, so I can go up and down, but I can go a little bit side to side as well. And then we have the saddle joint, which also is the up and down and side to side, but it's a little bit of a deeper movement. Okay, so it's a little different from the condyloid joint because I have a little bit more flexibility in that bone. Remember, our example of that is right at the base of the thumb bone between the carpals, which is in my wrist, and then this base part of the bone that makes up our thumb in our palm. Okay. We talked about stable joints and unstable joints. So stable joints are ones that have a lot of ligament holding the bones more tightly together and muscle holding the bones more tightly together. So we don't have quite as much mobility in a stable joint, okay? But then it's not going to dislocate as easily. Where if we have an unstable joint, we have a lot of movement around that joint, right? So it's less stable, okay? Because the ligaments maybe aren't as tight, the muscle's not as tight around it. So more mobility, right? But then more prone to dislocation. Okay, so that's the quick review of what we've done. What we're going to do, so the next thing we're going to talk about is something called proprioception. Proprioception. So back in kindergarten, you guys learned about 5 senses, right? Touch, taste, smell, hearing, and sight. Okay, so you learned about 5, but we do have more senses in our body than just that. And this one here is called proprioception. And proprioception is what allows us to determine where our body parts are in space without actually having to look at them, right? So I can put my hand up like this. I don't have to look at it. I can put my hand up like this, and I know my hand is up. I know my arm is bent now. I know that I'm at a right angle. I can feel it, right? I don't have to see it. I can feel it. So those messages get sent to my brain. And it's all because we have these little receptors. So when I talk about sight, I have receptors in my eye that can detect light. Okay. When I talk about hearing, I have receptors in my ear that can help me to detect the different sounds, right? Proprioceptors are receptors that allow us to detect body position. Okay. And we find these guys in our muscles, our tendons, and our joints. Okay. So that's where these types of receptors are found. And they tell the body about where our body parts are, right? So I don't have to look. I can close my eyes and I know if my knee is raised or down. Okay, I don't have to look at it. Tells us how much our muscles contracting. So whether I have a little bit or a lot, right? I can feel that I'm contracting a lot versus I have my muscle not being contracted at all, right? That's proprioceptors that are getting that message, and then they're sending that off to my brain. Tension of tendons, so how much the tendon is pulling. Again, there's proprioceptors there that allow me to detect that. So those help us to maintain our muscle tone and our good posture because we're sending those messages. We know when we're slumped over versus whether our posture is good, right? Proprioceptors send that message to my brain. Help us assess the weight of an object, right? When I lift something up, you guys, some of you may have had a tour of the Royal Canadian Mint. So at the Royal Canadian Mint, so that's where they make all of our money. And there's a place in Winnipeg. So at these places, there's one in Ottawa as well. And at these places, they have a gold brick. And you can lift up that gold brick. Okay? And it doesn't look all that heavy when you just look at it. And then you lift it, and then your proprioceptors are like, whoa, heavy, more muscle contraction. And then your brain can respond by that by increasing that force, right? Just like if you start to lift something up and it's a lot lighter than what you thought, right? You lift it up really fast, and then your brain responds like, okay, I don't need as much muscle, right? That's our proprioceptors. So they allow us to figure out how much muscle we need in order for that to work. Okay, so we're going to just watch a little YouTube video on proprioception. So I will share that with you. Excuse me.
So Lit Mobile just sent me this solar wireless battery pack. I'm excited, let's see what's inside. I really like the
Welcome to Moo Moo Math and Science and our sixth sense, proprioception. Proprioception helps your body know where it is in space. For example, when you're hitting a piñata, proprioception gives your body feedback so you know the location of your arms and hands without looking at them. Proprioception allows this juggler to catch the objects without looking at their hands. It would be impossible to drive an automobile because a motorist would not be able to steer or use the pedals while looking at the road ahead. A person would struggle touch typing, and people would also struggle walking without watching where they put their feet. Proprioception comes from sensory nerve endings that provide our brain with the information of the limb position. There are specialized nerves in your muscles and joints that communicate with your brain and tell it what position your joint is and how much stretch or strain is on the muscles surrounding a joint. The proprioception nerves create a system of communication with your brain about what is happening to the muscles and joints of your body. Most vertebrates possess three basic types of proprioceptors: muscle spinders, which are located in skeleton muscle fibers; Golgi tendon organs, which are found where muscles and tendons attach; and joint receptors, which are found at joint capsules. These receptors detect limb velocity and movement, the location of a specific joint, and if a muscle is contracted or stretched. These receptors also combine this data with information from sensory neurons located in the inner ear. If you'd like to know more about our senses, this playlist will help. And as always, thanks for watching.
Okay, so a little bit about proprioception. So we'll go back to our PowerPoint here. Okay, any questions about that? All right, so just so you understand, there are more than the 5 senses that you were taught in kindergarten. The 5 senses you're taught in kindergarten are more senses that are more tangible, right? Where proprioception isn't really something that's tangible, that's why it's not taught in kindergarten, but it is something that our body uses all the time, okay? And then our brain kind of fits that together. They talked about our inner ear because our inner ear is responsible for balance, not just hearing. So those messages actually can come together and help us with our balance as well. Okay, joint structure. So we're looking at the movement of joints. So joints, based on how the bones of the joints fit together, some joints have greater flexibility than others. So for example, ball and socket joints allow for more mobility. So, sorry, let me go back to my title here. What we're looking at are factors that affect how joints move, okay? Whether joints can move a little bit or whether joints can move a lot. So what factors affect that? Okay, so our first factor here is how is that joint fit together? So that's kind of what we were looking at with stable and unstable joints, right? So based on how that joint is put together can affect how that joint will move, right? So if I have a ball and socket joint, right, like in my arm, I have this movement where I can move my arm like this and I can move it up and down and I have all of these different planes of motion, right? But if I look at the joint that makes up my finger here, right? I have a lot limited motion around that joint. So if I hold my knuckle, right? So if I have my knuckle, I can move my joint like this around my knuckle. I can move up and back like this and around. But if I just look at the joints in my finger, I can't really do much other than just up and down, okay? So the structure of that joint, how the bones fit together in the joint, the muscle around the joint, the ligaments in the joint, all of those affect the movement of that joint. So the number one thing that affects our joint is the structure of it, right? So what type of joint that we have, and then the muscles, etc., associated with it. So even when I look at my ball and socket joint in my shoulder versus my ball and socket joint in my hip, I have a lot more movement in my shoulder. When I look at my hip, there's only so far I can move my legs because I've got bones that are kind of around it that are preventing that leg from moving a lot. Where here, I don't have any bones around my shoulder, I have a lot of movement in my shoulder, okay? So the structure. The other factor is flexibility around the joint, okay? So how much stretch there is in the ligaments around the joint, how much stretch there is in the muscles around the joint affect the movement around the joint, okay? So more tension in the ligament or muscle can decrease the movement around the joint. Whereas if it's more flexible around there, I can have increased movement around the joint. Some people are born with this increased flexibility around the joint where they can contort their bodies into all sorts of different positions because they have increased flexibility. But the deal with that is, with increased flexibility also comes increased risk to dislocation. Okay. And then temperature. Okay, so when the soft tissue around the joint is warmer, there's more movement around the joint because the warmth actually does work to increase the flexibility. And that's why before we do any kind of workout, we're supposed to warm up, whether we do just a quick 2-minute run or jumping jacks or something, it warms it up, and then that increases the movement around that joint. Okay, so warmth. All right, so those are the factors that affect the movement of the joints. Okay, now the other thing that's in this part of the curriculum, and we talked about this in our very first unit, is muscle movements. Now, how they relate that here is we're talking about movement of a joint, so muscles allow us, right, to move the bones around a joint. But then we need to know the names of these different types of muscles. So the agonist, which is also known as the prime mover, is the muscle that's actually responsible for the action. Okay, so that's the muscle that we need for that action to happen. The synergist is the muscle. So syn is a prefix that means together. So a synergist is a muscle that helps with the movement of the agonist. Okay, now some textbooks call anything that's helping the agonist a synergist. Some call things that help with the muscle moving in that direction a synergist, and muscles that stabilize the bone to assist that movement are called stabilizers or fixators. For our purposes, we're just going to call them all synergists. Okay. And then the antagonist is the muscle that produces an opposite effect. Okay. So if we have muscles working in pairs, an agonist and an antagonist, they both can't contract at the same time. One would have to contract while the other relaxes to allow for that movement to occur. Okay, so I have a couple of examples here. So this one we talked about in our very first unit back in February, which seems like a very long time from now. Flexing the arm, right? So I want to flex my arm. Well, in order to flex my arm, right, I need to contract my biceps. Okay, so my agonist to flex my arm is my bicep. That's this muscle here. My synergist is helping with that. The synergist, and remember we talked about this muscle as well, that's the brachioradialis. So that's the synergist. That's helping. It's a helper muscle. It's not the main muscle in this movement. And then the antagonist, which is the muscle that needs to relax to allow this movement to happen, is my tricep. Okay, so when I flex my arm, my bicep, should all plugged in here. My bicep is my agonist. My tricep is my antagonist. That's the one that has to relax. And my synergist, the one that's the helper muscle, is the brachioradialis. Okay, so we're going to do a couple more examples. If I'm going to extend my knee, right? So I'm going to go from my knee being bent to my knee being extended. All right, so the muscle that's responsible for that is actually a group of muscles. So that's all these guys here, the quadriceps. Okay, so there's a few muscles responsible in our quadriceps, but we'll just call them the quadriceps. So the quads allow me to flex my knee. Okay, but if my quadriceps are contracting, then my hamstrings have to be relaxing. Okay, and then my helper muscles, these are all the adductors. So they're going to help stabilize and keep everything in position to help for the bending of my knee. Okay, and then our last example we're going to talk about is extending the ankle. Okay, so we're looking at plantar flexion. Okay, so we're extending the ankle, so we're pointing our toes out. Okay, so to point our toes out, we have the gastrocnemius, remember that's our calf, and the soleus. So these muscles here at the back of the leg are responsible for that. Okay, the antagonist is the muscle here in the front of the leg, the tibialis anterior, is connected to the shin. And then the helper muscle is here, that's the fibularis longus, that's helping that action to occur. Okay, so we need to know what a synergist does, what an antagonist does, and then what the agonist is. Okay, and then you should be able to give me a couple of examples of those. Okay, lastly, we have range of motion, and we did talk about this again in our very first unit back in February. But range of motion is referring to the amount of movement around the joint. So we're looking at different range of motion type exercises. So if we have an active range of motion, right, this is our range of motion when we are freely moving. Okay, so that's our range of motion. that are carried out by the individual. It's their muscles. So range of motion exercises. So we're bringing that movement around a joint, okay? And we can increase the flexibility at the joint. Eventually it can reduce pain, okay? Increasing the flexibility helps to reduce the pain around the joint because it's not holding that joint so tightly together, and works to improve our balance and our strength, okay? Passive range of motion. So my image here has this physiotherapist helping with the movement, okay? Passive means the individual isn't responsible for the movement at all, okay? The physiotherapist, or you could have an external source like a machine, is using the energy. So the individual's not using any energy at all in order for this to happen. Again, helps keep the joints flexible. You might be doing this for different types of exercises you're doing for physiotherapy. It could be an individual who's paralyzed, but wants to keep that joint moving, right? Or maybe someone who's been in a cast for a while. Helps muscles that usually move, or sorry, the muscles that usually cause that joint to move aren't working at all. Okay, so we're not doing any muscle work there. So it's not going to increase the strength of your muscle because your muscles aren't doing anything. But usually it's going to exceed the active range of motion, right? Because when you're doing the motion by yourself, you have some limitations to how far your muscles can pull. When it's passive, right, we can go a little bit further because someone's putting that pressure on us, right? It's their energy that's being exerted, not ours. And then lastly, we have restricted range of motion. This is when we're moving against an opposing force. So this is my example I have here with a band. So using a band, if we're pushing against weights. So anytime our range of motion, we are pushing against something, right? That's a restricted range of motion. So often this is used to increase muscle strength and endurance. Okay. All right. So that is it for today. I did, like I said, share that worksheet with you. So we're ending 15 minutes early, which gives you an extra 15 minutes to work on that worksheet and get that done. Class on Friday, we'll talk about conditions and I'll give you your assignment. And then on Monday, and I will write this in your notes as well, but on Monday you will have your joints and muscle quiz. And yeah, and I have a chat here. Yeah, I can go back to the active range of motion slide. Absolutely. Just give me 1 second here. There we are. And we can see that the leg isn't moving quite as much with the active range of motion as with the other one. Any other questions? Okay. Yeah, no worries, Carly. Yeah, so Ethan's just asking, what do we have to work on? Just the joint sheet that I handed out today. So that's it. That's due on Friday. And like I said, you should probably be able to get that done within the next 15 minutes, maybe an extra 15 minutes. Yes, every worksheet can still be handed in, Harleen. So anything up until June 16th. After that, it's a zero, permanent zero. Okay. Any other questions? Oh, no worries. All right, guys, so we will sign off for today. So have a lovely day. So just get that done and then you should be good to go. All right, we will talk to you on Friday. Oops.